Hi bachcho, how are you? Today we are discussing 24 January 2026 shift 1 JEE Mains physics paper. Okay, so shall we start the session? So one by one we can see each and every question. We can move for first question. So what is the first question? So the 26th question according to your paper. So the density of water at 4 degrees Celsius and 20 degrees Celsius are this one and this one respectively. So the increasing in internal energy of 4 kilogram water when it's heated from 4 degrees Celsius to 20 degree Celsius. Okay, so that what they will ask, internal energy delta U they will ask. So according to the thermodynamics first law, delta Q equals to del U plus del W. So what is the my delta U equals to del Q minus del W. Okay, so what we can see here, easily first we can find what is the my heat supply, delta Q, ms delta T. So for mass of the this one, that is 4 kilogram, and the specific heat of the water, that is 4.2 joule per kilogram. So we need to convert this one, so 4200, okay, into change in its temperature, that is my 4 to 20, that is 16. Okay, so just do this calculation. So delta Q we can get approximate 2 4 4 16 16 into 4 64 into this one 200. So this just you can solve this calculation, then you can get approximate 268800 joule. But how to we can find del W? Del W equals to P delta V. So here I am just writing P delta V. So pressure is also given, 1 atmospheric pressure 10 to the power 5, delta V change in its volume. So volume equals to mass upon density. So P into V2 minus V1. So the final M is my same mass only for 4 kilograms. So what is the my final density? That is 998 minus M, that is 1000. So just you can do this one, M you can take common out, and this one. So 10 to the power 5 into mass of this one is 4, 2 divided by 1000 into 998. So just we can solve this calculation. 5, 3 power is cancel out here, 4 into 8, 8 divided by 4 into 2, 8, this 3 is cancel out, only power 2 is left here, and 9, 9, 8. So just you can do this calculation, then you can get 0.8016. So what is the my change in its internal energy? Just you can put the both values are here. Delta U equals to 26800 minus 0.8016. So just we can subtract this one, so we can get 268,799.2. So which means option first one is your correct answer. So this is our first question for the JEE Mains. Okay beta. Next one. So in a microscopic tube, length of this length, so the microscope tube length is 10 centimeter. Two concave lenses are arranged with focal lengths of 2 centimeter and 5 centimeter. Total magnification obtained with this system is normally is 5 power k. So the value of k they will ask. So all of you now, this is not a simple microscopic, this is the my compound microscope. So what is the my magnification formula of the compound microscope? M equals to length of tube divided by focal length of objective lens into D divided by focal length of the my eyepiece. So everything is given. Length of tube is 10 centimeter, focal length of the object lens, two convex lens are arranged length of 2 centimeter and 5 centimeter. Okay, so the length of my focal length of the object, that is 2 into d is 25 divided by f is 5 centimeter. So 5. So what is my final answer? That is 25. So 25 is my 5 power 2. So what is my k value? So just you can compare with this one, 5 power k. So what is my k value? K value equals to 2. So which option? 3 is your correct answer, beta. Okay, so nothing is there, just you can use the magnification power of the compound microscope and just tube of the length, focal length of the object lens, eyepiece, and this d value. Okay, so d is my least distance of the diameter. Next question. So option third is your correct answer here, beta. Next one. So two electrons are moving in orbit of hydrogen like atoms with the speed of this one and this one respectively. If the radius of these orbits are nearly same, okay, radius are same, nearly same, then the possible order of energy. So beta, all of you now, what is the my radius? R is proportional to n square upon z, and both are same. Velocity is inversely proportional to n square, and energy is my z square upon n square. Means here you can see hydrogen like atoms, means my z equals to 1. Just you can put z equals to 1 because H like atom. So my energy is proportional to 1 upon n square. Okay, means 1 upon n square means my E is proportional to my V. Okay, oh sorry, V is only for n, not n square. Okay beta, my velocity only for proportional to the 1 upon n. So what is the my E, relation between E energy and the velocity? Energy is proportional to my V square. You can easily see here. So is, so just I will take the ratio of E1 by E2 equals to V1 by V2 whole square. Okay, so V1 by V2, so just you can put V1 and V2 value here. That is V1 is 3, 10 to the power 5 to 5 is cancel out, 3 divided by 2.5 whole square. So this will be 30 divided by 25 whole square. So just you can solve this one, 6 by 5 whole square. So they will ask what is my energy order here. So energy is reversely proportional to this one. Okay, so energy is 1 upon n square. You can easily see here 1 upon n square. So E1 by E2 okay, so n2 by n1 equals to 6 by 5. So the order of my energy is 6 and 5. So which option? Option 4 is your correct answer beta here. Just you can compare what is my radius relation, what is my velocity relation with the number, and energy relation is this one. Okay, Z is the atomic number, N is the energy level. So just you can compare. Okay beta. So 28th question, option 4th is your correct answer. Next question, what they will ask? Next one. So there are three concentric conducting sphere of cell A, B and C, radius A, B and C are respectively. C is less than B and A. A is the my outer radius of this one. Okay, and they are charged with charge Q1, Q2, Q3 are respectively. So the potential of the sphere A, B, C respectively are. So beta, all of you know what is the my potential due to a spherical cell. I am just telling here. This is the my beta spherical cell and its radius is R. Capital R I will just consider. okay, capital R. If some charge is here, so and so what is the my inside potential? KQ upon R. What is the its surface? And what is the my, if I am just considering one point is here and its distance from center is R, so what is the my V out? KQ upon R. Okay, so according to this we are just solving this question. So this is the my A, okay, this is my B and this is my C, because C is less than. It is A. So just you can see here what is the my potential due to C. Okay, I think there is the correction in A is outer side. This is the reverse of this order. Okay, just we can see in this way, no problem. Okay, so what is this? First we can find if my charge is on surface first A here. So what is the my potential? Vc equals to K Q upon its radius is C. Then some charge is here. Just then you can see due to this circle there some point charge is here. So what is my potential outside this one? That is KQ upon R. So plus KQ upon B. Similarly you can write KQ upon A because the charge is outside the ring. Okay, then we can move for the second cell B. Okay, V8B, that is due to this is the my cell. Okay, so due to this cell this charge is inside this my cell. So what is the potential due to this one? That is K Q upon radius of outer, that is B, because here you can see at the surface and inside KQ upon R both are equal. So just you can put KQ upon R. If my charge is on the cell B, so what is the my potential? KQ upon B. And third charge is outside the my cell, means it is outside the radius of this one is A, KQ upon A. Similarly you can find for the third charge. Okay, so due to third VC equals to KQ upon C, because KQ upon A. Okay beta, so just you can see one thing here, all the charges are inside the my outer cell A. So KQ upon A plus KQ upon A plus KQ upon A. Okay beta, so which option is your correct here? Option 4. So this order is reverse beta. Okay, if A is here and C is here, then our option is the this one is correct beta. Okay, so just you can write here easily, you can see same process, nothing is changed, just this order is changed here. Okay beta, so option 4th is your correct answer. Okay, but according to the question, if this value is current up to I remember, if this is the final this way, so A is outer, so option first one is your correct answer here according to the question. Okay beta, if this order is reversed, then my option 4th is the correct answer beta here. Okay, okay, so we will move for next question. Okay, not for first one is, so the an unpolarized light is incident at an interference of a two dielectric medium having the refractive index 2 and √3 respectively to the satisfied the condition the reflected and refracted rays are perpendicular to each other, the angle of incidence. Okay, angle of incidence they will ask. Okay, so that is very easy question, just we can see here. Okay, so what is the my condition of the minimum? Reflected and refracted are both are perpendicular, means I plus R equals to 90. Okay, so R equals to 90 minus I. So all of now just we can use the Snell's law. Okay, Snell's law means N1 sin I equals to N2 sin R. Okay, so R equals to 90 minus I means cos I. Of I. So this will become in this side, so tan I N2 upon N1. So this value is N2 upon N1 means N2 is 2 root 3 divided by 2. So this will be cancel out. So which angle? Root 60 I equals to 60, because that value is my I equals to 60 degree. Okay beta, so which option? Option 2 is your correct answer. Next one, so match the list of first one with the second one. Okay, so first, what is the magnetic induction? F equals to Q V B, B equals to F upon Q B. What is the my dimension of force? M1 L1 T minus 2. What is the my dimension of charge? That is my ampere into per unit time charge, current per unit time, so A into T minus 1. What is the dimension of velocity? Velocity is meter per second, so L1 T minus 1. So this one you can solve, then you can get M1 L0 T minus 2 A minus 1. Okay, because L1 L2 L is cancel out. Okay, so which option is correct for here? M L0 T minus 2 A minus 1. So first one is matching with my third one. Similarly, magnetic flux phi equals to B dot A. So just you can multiply this dimension with my A. So A is also cancel out, means M L2 because L is 0 here. So area phi equals to B dot A. B is the magnetic induction and A is the my area. Area is the dimension of the area is meter square. So meter square means L2. So just you can multiply with the L2. So M L2 T minus 2 A minus 1. So which one? Second one is with my 4. So the magnetic permeability. So force per unit length mu naught I1 I2 upon 2 pi r. So my length is also in meter, r is in also meter, so this will be cancel out to each other. So what is the mu equals to F upon I2, because 2 pi is the constant, that is the my dimensionless quantity. And what is the my dimension of M1 L1 T minus 2 divided by I. What is the my current? Ampere, so A power 2. So M1 L1 T minus 2 A minus 2, that is my option first, and remaining is the my magnetic self inductance. So U equals to half L into I square, dimension of energy M1 L2 T minus 2 and IU now A square. So L equals to, you can get easily, that is the my M L2 T minus 2 A minus 2, that is the option second. So which option is correct? First one with third, only two options are left. 2 and 3 is wrong, first and fourth is left. B with my fourth, yes, B is also fourth, that means again correct here. Third one C with match with me, C magnetic permeability is M. Okay, M L2 first one, so option fourth is correct answer, not third. So option fourth is your correct answer. This is the just dimension based formula, dimension related to question. Next one, for a series LCR circuit connected with 220 volt 50 hertz AC source as so in the figure, the power factor alpha upon 10, the value of alpha. So beta, what is the my power factor? Cos phi. Cos phi equals to, all of you now, R upon Z. Power factor cos phi equals to R upon Z. Okay, okay beta. So just you can do the calculation of this one. What is the my Z in the impedance? So cos phi Okay beta, so just you can do the calculation of this one. So cos of phi, okay beta, so cos phi equals to this one, cos phi, XL value is my 70, XC value is my 50 and R is the 60. Just you can put here, just I am doing calculation here. Okay beta, here that is okay. R is my 60 square root of 150 minus 70 60 square. So beta, just you can subtract this one, 50 20 80, 60 divided by square root of 80 square plus 60 square, 10 power 2 is you can take common out, so outside is only 10 is coming, so this will be cancel out this one. Okay, so 6 divided by 8, 8 is sorry this one is square. Okay beta, so what is the my 8 square, 64 and 6 square is 36. So what is this, 100? So 6 divided by square root of my 100, this will be 6 by 10. So what is this, you can just compare with this one, alpha upon 10. So alpha equals to, you can get 6. Okay beta, 6 is the final answer. Option third is your correct answer for 32 question. Okay, next one is my 33. Okay, 33. So beta, this is the not ratio wave, radio wave, radio wave. So what is the my radio wave, and second one is the microwave, infrared and X-ray wave. These are the methods how to we can produce the radio wave, microwave, infrared and X-ray wave. Okay, so this is the first one is the radio wave due to the accelerated charge. Okay, first one is with my fourth. Okay, second one is my microwave. Microwave is produced by magnetic magnetron value. Yes, okay, so magnetron value. Third one is infrared. Infrared is due to my charge vibration mode of atoms, means, so the infrared how to we can produce, so the vibration mode of the my atoms, so which means option 2. Next one, X-ray. X-ray is when my electron is coming higher energy to lower energy. Okay, so due to the inner shell of electron moving from higher energy level to lower energy level, means is with this one. So first one with fourth. Okay, so these two are wrong here. Oh sorry, only second one is wrong here. Second one with my microwave is produced by magnetron value, means B is match my with 2. Okay, so this will be also wrong here and this will be also wrong, and you can get easily answer. Only you can match the two options, then you can get easily answer for this quiz. Okay beta, next one, a cylindrical block of mass m and area of the cross section is A, floating in liquid of density rho with x is vertically when depressed in a little in the release the little and release the block, start oscillate the periodic oscillation of this one. Okay beta, I am just making diagram here. This is the my container and up to this one. Okay, a cylindrical block of mass m, its mass is m. Okay, and its depth, initially depth I will just consider h is inside the my liquid. When we are little bit pressed this one, so if there is no external force is there, so which type of force are working here, mg is downward direction and fb bouncing force is my upward direction. Okay beta, so just first you can balance these things. Okay, then so here my rho gl fb equals to density of liquid and g into this height h equals to mg. Okay beta, when I will press this one, so there is some force also working here, means, and that time I will just consider its length is little bit, this will be coming more down, so I am making second diagram here. Okay, so it's this height I will just considering x. So what is the my new force of this one? So just use the equation of kinematics, F equals to what is the my binding force? Both are reverse, so I am just writing here. Okay, net force F equals to my rho L G into H plus X minus mg, because mg is always downward direction. So this one. So what is the my F equals to m into a and rho L g, okay, H plus rho g x minus mg. So mass of this one m rho equals to m upon v. So v, just you can multiply this one with my v, okay, rho g h, okay. So just this one you can put, and v, density of liquid into v into mass, this is the mass of this one, so rho L v, okay, into z. So this value you can do, so rho gx, so v equals to area into this one, so this will be cancel out here, okay beta. Oh sorry, it's volume, okay, rho L a, okay beta. So rho a is also here because it's volume, so v equals to area into its length, its height, so here is also a, volume of this one, area into its length, height h initially, a into h into z. So this will be cancel out here my, so m a equals to rho a g x upon m, sorry, I am just considering what is the my a equals to this one. So all of you now, what is the my a equals to omega square x minus omega square. So just you can compare with this one. So what is the my omega? Omega equals to, you can get rho a g upon m, and square root of this one is also, what is the my time period? T equals to 2 pi upon omega. So omega you can put here, so m is going up, so T equals to 2 pi root m m upon rho ag. Option second is your correct answer beta. Just you can put this value is here, okay, then you can get answer, okay. So this is the final answer for this one. Next question, option 2 is your correct answer. Again same question, okay beta, no problem. Next one. So there are below two statements. In the light of above the statement, choose the correct state. So statement first, for all the elements greater than the mass of nuclei, greater is the binding energy per nucleon. No, first it will be increasing per nucleon binding energy up to 56, okay beta. After 56 it is decreasing with the my mass number, so that's why first one is the wrong. Second one, for the all elements nuclei with less binding energy per nucleon transfer to nuclei with greater binding energy per nucleon. Yes beta, the less binding energy nucleons are using the my nuclear reaction fission or fusion, and they are convert with the greater or higher binding energy per nucleon. So that's why my statement 2 is correct. So first one is the false and second one is the true, okay. So option 4th is your correct answer beta here, okay. Next one. So the electrostatic potential in a charged spherical region of radius r varies v equals to ar cube plus b, where a and b are constant. So the total charge pair of unit radius is alpha into pi a naught. So the value of alpha they will ask beta. So my v is given. So all of you now, electric relation between my electric field and the potential, E equals to minus del v upon del r. E equals to, just you can do the differentiation of this, okay. So that is r cube, so 3 a into r square, because a and b are constant, so b is 0, so negative is also there. Okay, so this is the my electric field. According to the Gauss law, what is the my flux? Gauss law, phi equals to E dot A. Okay beta, this is E is my E value is this one. Okay, so E value is this one, so phi equals to E dot ds equals to sum is charge of this one upon epsilon naught. So what is the my E? That is minus 3a into r square. What is the area of space? 4 pi r square and equals to q upon epsilon naught. So the electrostatic potential in a charge spherical region of radius r varies with, okay, this one way and bit, so the total space, so vacuum is, okay, so just you can multiply, so minus 12 pi a r power 4 equals to q. So this much charge beta. Okay, so what is the my alpha value? Pi into a naught, this one you can consider. So the minus 12 is the my final answer, because r you can just consider 1 here. Okay, 1 meter. So option third is your correct answer beta here. Next question, so option third is your correct answer. Next question, 3 charges plus 2q plus 3q minus 4q are set at the 0 comma minus 3 and 2 comma 0 and the minus 2 comma 0 respectively in the xy plane. So the resultant dipole moment about the origin. So this is the my xy plane, so it is my origin. First one is plus 2q is put minus, so what is the plus 2q, and second one charge is 2q 2a comma 0 and what is the charge? Plus 3q. Fourth one is the minus 4q is at this way. What is the charge? Minus 4q. What is the my dipole moment? P equals to q into r. So total dipole moment q into, so q1 r1 plus q2 r2 plus q3 r3. Okay, so first one charge is plus 2q. What is this one? Minus 3 a j cap, sorry, I cap, plus second one is 3q into 2a I cap, plus fourth one is minus 4q. So plus minus is minus, so minus 4q into minus j cap, minus 2a j cap. So just solve this one beta. So plus 2q I cap, so plus 2q you can take common out. Okay, so the final answer you can get for this one 36. Okay, so q minus 6 and 6. Okay, somewhere I will do mistake, yes or no. Oh, this is on my y axis beta, not on x axis. That's why I will think where I do mistake. On minus 3a 2a comma 0. Oh, sit. And third one is charge minus 4q. Okay, and second charge is put on first charge, there is the my minus 3a, minus 3a and the charge value is plus 2q. Plus 2q. So just we can solve again this one. Okay, so first one charge is at my plus 2q at minus 3a cap. So plus 2q into minus 3a means minus j cap. Second one charge is my plus 2a means on x axis, okay, that is 2a and charge is 3 plus 3q into a 2a minus 4q minus 4q is put at 8 on axis, that is minus 2a, so 2a j cap. So this one you can solve, then you can get better right answer for this one. So first minus 6a j cap and the second one is I'm just writing here 6 minus, sorry, we can just put in the 6 aq j cap plus 6 qa I cap plus minus and minus, there is minus is also, okay, because it is on minus x axis. So minus minus plus, okay, plus 8 j cap, okay beta. So just solve this one beta, so you can get final answer, that is the 2qa upon 7i minus 3j, okay. Again this question. Next one 38. So the two resistors of 100 ohm each are connected in series with 9 volt battery. A voltmeter of 400 ohm resistance is connected to measure the voltage drop across one of the resistance of the voltmeter is V, okay beta. So two resistance are in series, okay, each are connected in series, and 9 volt battery of 9 volt battery, okay, and voltmeter of this one is connected to measure the voltage drop across one of the resistance, so the voltmeter reading, so it is connected to with parallel, okay. So 400 100 100. So beta first you can find what is the my R equivalent. So R equivalent just you can find for the first two R1 equivalent. I am just writing R1 equivalent. Equivalent, that is 400 into 100 divided by 500. So 400 by 5. So this value is 80 ohm, and this 80 ohm is with series my 100 ohm. So what is the my R equivalent? R equivalent of the circuit, that is my 180 ohm. So what is the my current in the circuit? That is current in the circuit, that V equals to IR. So R is my 180, so I equals to 9 by 180. So this value is 0.05 ampere. So what they will ask, voltage drop across any one of this one. So here I am just connecting. So what is the my voltage drop across this one? That is I into R1 equivalent. So I is 0.5, so 0.05, and R1 equivalent is my 80 ohm. 80 ohm. So this value you can get okay, 4. So option B is your correct answer beta here. So the reading of the voltmeter is 4 volt, okay beta. So the two masses of 400 and 400 gram and 350 gram are suspended from the ends of a light string passing over a heavy pulley of radius 2 cm. When released from the rest, heavier mass is observed to fall 81 cm in 9 seconds. So the rotational inertia of the pulley is in kilogram into meter square. So beta just I am making the diagram here. This is the my pulley and its radius is my R, okay, and their two masses are connected. 350 gram. So this is the my pulley system. Okay beta, so what is the my tension in this one? T1 and T2. This is the my mg, and its acceleration of this one is a and this one is a. So just you can write the my equations only here. So T1 minus upward direction, you can take the okay, I am just writing here. So what is the my equation? So T1, this is in the gram, so we need to convert into the kilogram. So T1 minus, oh, T1 is of 1, so T1 minus 0.4 into mg. Okay, g I will just write g. Okay beta, just I am writing g. T1 minus 0.4 g equals to m 0.40 a. Okay, similarly you can write for the my T2. Okay, so what is the my T2? T2 minus 0.35, sorry, T2 minus 0.35, and oh sorry, there is the also negative, because downward direction we are considering as a negative. Okay, and T2 minus 0.35 g equals to 0.35 a. Okay, next one, what is the my torque? Tau equals to r cross f. So for this radius is r, at torque we can consider here tau, and due to this pulley tension is T1 and T2. So what is my force? T1 minus T2, and its distance is r and radius is r. Okay, so its distance is r. So T1 minus T2, this value you can put here, and tau equals to I alpha equals to T1 minus T2 upon into r, and a equals to, all of you now, r alpha. So alpha equals to, you can put a upon r. So I equals to you can get T1 minus T2 into r square. Okay beta, so this is the my momentum of inertia. But what is the my second condition? Okay, sorry, a upon r. So a is also here. So how we can find a? So this condition you can remember, 2 centimeter release from the rest. Okay, so the radius of pulley is 2 centimeter when released from the rest, means it is released from rest. So it's 81 centimeter in 9 seconds. So s equals to ut plus s equals to ut plus half a into a is t a into t square. So what is the condition? It released from the rest means the heavier mass is, its displacement is 81 centimeters. So 0.81, okay, equals to initial it is 0. So 0 plus, because it is released from rest, so my velocity of the system is 0. Half into a into t is, it will be 9 second. So 9 square. So here you can get a value that is my 0.81. So I will 100 equals to 1 by 2 into a into 81. So 81 to 81 is cancel out. So a equals to, you can get 1 upon 50. Okay, so everything is you have. So just you can put here beta. I am just putting everything is here. So 1 by 50 into I equals to T1 minus T2. So T1 equals to, you can get 0.4 g minus 0.4 a, okay, minus T2 equals to, you can get 0.35 a plus 0.35 z. Okay, so and what is the my radius of this one? That is 2 centimeters. So 2 into 10 to the power minus so radius is my, I am just writing here 2 into 10 to the power minus 2 square. Okay, but just you can g equals to, you can put 10 okay, oh sorry, 9.8, and A equals to, you can put 1 upon 50, radius is there, and you can just also multiply by 50 also. So just I am doing the calculation, 0.4 G minus 0.05, okay, 0.05 G, okay beta, minus plus 40 plus 35, 40 plus 35, 70, 75, minus 0.75. 75A, okay, and radius is this one, okay, again I am here and into 50. So just A value you can put and G value you can put, just you can solve this one, then I will just write directly answer here, calculating this one 0.0, so I equals to 0.75, and acceleration of this one is 1 upon 50, and radius of this one is 2 into 10 to the power minus 2 whole square into 50. So this one you can solve, then you can get 9.5 into 10 to the power minus 3. This is my final answer for this one. So that is the option 3 is your correct answer beta here. Okay, so nothing is there, just you can set make the free body diagram of this one and use this simple formulas are here. Okay, so what is the my next one, next question. Okay, so a body throws ball in the air at 45 from the horizontal to land on the roof of a building of height h. Okay, if the ball is attains maximum height in 2 seconds. Okay, so what is the my time period formula? T equals to 2u sin theta by g. Okay, this is the complete projectile motions time period. Okay, and land on the building after 3 seconds, launching the value of h in maximum. Okay, so the height of building they will ask. So what is the my time period for the maximum height? T equals to u sin theta upon g. Okay, so what is the my angle? Angle is the 45 and u is just, you can, and g value you can take 10, and time period is 2 at maximum. Okay, 2 equals to u by g into 1045 sin 45, that is 1 by root 2. So u equals to 2 root 2 into g. So this is the my velocity of the part. Okay, so the building height h, if the ball is attains maximum height in 2 seconds and land on the building after 3 seconds. So what is the its height? So if I will throw suppose here, and it will be take time 2 and reaching there 3 seconds. So s equals to ut plus half a into t square. Okay, so its initial speed 2 root 2 into g and its time is t. Okay, minus 1 by 2 because acceleration due to gravity is downward direction. So 1 by 2 into z, 3 square is 9. Okay, so just this one you can solve. So h equals to 2 into 1.14 into 10 into 3 minus 5 into 9. So this value you can get approximate h equals to 15 meter. Okay, option first one is your correct answer beta here. Okay, so anyone doubt in this one? No. Okay, next one. So the a brush of wire length 2 meter and the radius is 1 mm at 20 degrees Celsius is held to the between two rigid supports. Initially it was cooled to the temperature of minus 43 degrees Celsius, creating a tension T in the wire. The temperature to the which the wire has to be cooled in the order to increase its tension is 1.4 T. So they will ask in the second condition what is the my temperature of this one. So all of you know what is the my formula of thermal stress. So the thermal stress, F equals to Y, Young's modulus, A into alpha is the linear coefficient into delta T. So just F is my tension force. So initial temperature, brush wire of this one, so area equals to pi r square, both are the same, so these are the cancel out. Just you can focus on the temperature and the tension. So initial condition T equals to Y A and alpha T1 equals to which one to which one, minus 40 final, minus 43 minus 27, in T2 that is Y into A into alpha. My final temperature that I will consider small t, and it's start from minus 27. Okay, so just you can take the ratio of my T1 by T2. So T1 is the my T and T2 is my 1.4 times of T equals to Y A alpha is cancel out in both the conditions. So just I am directly write this value, minus 43 minus 27 divided by T minus 27. Okay, so T to T is cancel out and T minus 27 equals to 310 8 9 minus 90. Okay, so just you can solve this one. So this is the going that side, plus 1. Okay, anywhere I will do mistake. Okay, plus 90. So what is the my final answer for this one? That is 3. Okay, 10 minus 7, 8 minus 2 is 6, minus 65. I will get minus 63. Where I will do mistake, just I will recheck this one. Y equals to minus 43 to 12, minus 43, 7, 4, 6 into 7. Oh, I will do one mistake is here. This will I also not multiply. Just give me 1 minute. So T minus 27 equals to 1.4 into 4 minus 43, 7 and 3, 10. 10 means 0 and 4 to 6 and 7. So just you can solve this one better, minus 70. So T equals to, you can get that is minus 71. So what is the my final temperature of this one is that one, my 71. Okay beta, so nothing is there. Next one, so 3 masses of 200 kilogram and 300 kilogram and 400 kilogram are placed at the vertices of an equilateral triangle with the side of 20 centimeter. They are arranged from on a vertices of bigger triangle of side 25 centimeter, means the right now they are increasing the side of the my equilateral triangle. Okay, and the with the same center. So the work done in the process. So just you can find what is the my work done. W equals to change in potential energy. So what is the my U1, just I am writing first one formula, minus G M1 M2. Okay, I am just making one triangle here. Okay, first mass is 200, second is 300 and fourth one is 400. Okay beta, and its distance is 20 centimeter. So what is the my potential energy formula? U equals to minus G M1 M2 upon distance between them is R. So everywhere my distance is same. So G minus G M upon R I will take common out. I will just directly write here. U1 G upon R into M1 M2, that is 200 and 300, 6 into 10 to the power 4, next one 300 plus 12 into 10 to the power 4, and next one is 8 into 10 to the power 4. Okay beta. So what is the my distance between them? That is my 20 meters. So G value is 6.7 into 10 to the power minus 11 divided by 20 meter. Okay, so 20 into 6 26 into 10 to the power 4. Okay, so just do this calculation beta. One is cancel out this one, and this is the my 13. So what is the my u1? Easily you can write this one, 31 into 6.3, that is you can get minus, because already negative is there, minus 86.71 into 10 to the power minus 8. Similarly, if I will increase this 20 is increased by 25, nothing is changed, just my u final is minus 6.7 into 10 to the power minus 11 divided by this 20 replaced by 25, okay, into 26 into 10 to the power 4. So just you can do this one. So I am writing here what is the my u final value? U final value is, you can get, that is minus 69.26 only 1 point, this one, okay, 69.3 into 10 to the power minus 8. Just this value and this value you can put in this one. So W equals to u final minus u initial. So final is minus 69.3 into 10 to the power minus 8, and u initial minus 86.7 into 10 to the power minus 8. 10 to the power minus 8 you can take common out of this one. Okay, so the final answer 1.74 into 10 to the power minus 7, that is your final answer. Okay, so the work done is this one, 1.74. Okay beta. So this is the 42 question. Next one. So the two resistance 2 ohm and 3 ohm are connected in the gap of the bridge of as so in the figure. Okay. So the null point is obtained with the contact of jockey at some point in between x and y when an unknown resistance are connected in parallel with 3 ohm. Okay. Okay, 3 ohm resistor. The null point is shifted by 22.5 centimeter towards y, means in this way. Okay, so the resistance of unknown resistance is in this ohm. So what is the my condition of null point? P upon q, x1 r1 upon r2 equals to x upon null point distance from x and divided by 100 minus x. So 2 by 3 equals to its initial null point condition position x into 100 minus x. So just 100 200 minus 2x equals to 3x. Okay, okay. So what is the my x? X equals to 40 centimeter. Okay, centimeter. Okay, centimeter. Okay, so this is the my initial condition of the null point. When we are connecting this resistance, I will just consider R. Okay, so both are in parallel. So how we can find the R equivalent? R1 R2 divided by R1 plus R2. Okay, so I am just writing again the same condition of null point. So that is my 2 divided by 3R divided by R plus 3 equals to initial is 40 centimeter and it's shifted toward 22.5. So means we can also add this one. So 40 plus divided by 40 100 sorry 100 minus 40 plus 25, so 60 minus 22.5. So just you can solve this one. 62.5 divided by 38 38.5 37.5. Okay, so 37.5 80 38 plus 2 40 42 plus 60. Okay, and equals to this one 2 upon 3 r upon r plus 3. Okay, so this will be going up, so 2 into r plus 3 divided by 3r equals to 62.5 divided by 37.5. just you can cross multiply this one, so this point is also removed here, so 2 into 3 75 into r plus 3 equals to 3r into 625. so just you can solve this one, so r equals to, you can get, that is my 2 ohm. Option 4th is your correct answer beta here. Okay, 4th is your final answer. Next one, a spring of force constant 15 Newton per meter is cut into two pieces. If the ratio of their length is 1/3, so the force constant of the smallest smaller piece is Newton per meter. Okay, so if this is the my spring, so the my spring constant is inversely proportional to its natural length, so means spring constant and its length is always constant. So if I will cut into two parts and so what is the length ratio is 1/3. so first one I will just consider 3l/4, okay, and l/4. so that its length and its force constant k equals to constants, always constant, so k into l equals to smallest piece l/4, that is equals to k dash into l/4. okay, so l to l is cancel out, k dash equals to 4 times of its k. so 4 into 15, that is my 60. option 3 is your correct answer for here. Okay beta, so I think up to this one for third option. Next one, so the exit surface of prism with refractive index n is coated with the material of having the refractive index is n/2 when this prism is set for a minimum angle of deviation. Okay, so beta, what is the my condition of minimum deviation? r1 plus r2 equals to a. so the my r1 r2 both are equal, so r1 plus r2 equals to a, so r equals to a/2, so r1 equals to r2 equals to a/2. so they exactly meets the condition of the critical angle. so what is the beta my condition of the critical angle? so condition of the critical angle means sin c, it is coming from inside the prism and exact surface they will ask, so this will be coming. Okay, so it's coated with n/2 and its prism is n, so n2 upon n1 beta. Okay, critical angle condition n2 upon n1, so n/2 because it is exact from this one, so n/2 divided by n. Okay, so here sin c c equals to, because the condition of the critical angle prism angle is, so c r and r1 and r2 both all three are equal, so sin c equals to 1/2, that is my 30 degree. Okay, so c equals to 30 degree, so c value you can put here 30 equals to a/2, so a equals to, you can get 60 degree. Which option? Option second is your correct answer beta here for this question. Okay, next one is our I think numerical type questions are started now. If the given figure, the block A, B, C are weight 4 kilogram, 6 kilogram, 8 kilogram are respectively, the coefficient of the sliding friction between the two surface is 0.5. Okay, so the everywhere is 0.5, 0.5. Okay, F required to the slide block C with constant speed is in Newton. So beta, what is the my in 8 kilogram block? If I will apply this F external, so it is moving with constant speed. So what is the my F external? Yeah, F net, that is equals to 0. So first how we find the what is the my limiting friction between them, that is FL. FL equals to mu into N equals to mg. Only for A and B, that is N equals to 0.5 into mg of this one. First one, A block is my 4 kilogram, 4 into g equals to 10, 20. Okay, so this one FL equals to 20. Similarly for this one, FL equals to, you can get 50, and similarly for this one FL equals to 90, because all three mass. For B, mass of the A and B, mg equal m into g, m is the my 4 kilogram plus 6 kilogram, that is 10 into 10 into 0.5. For C, 18 into 10 into 0.5. Okay, so FL is the 19. So the condition of that net is equals to 0. So their tension is T, I am just considering. So the 90 plus T for 8 kilogram block, F 90 plus T plus this one also 50. What 90 plus its tension T plus this force is only 50. So what is the, this is the my 8 kilogram and this is the my, so this is for 8 kilogram block. Similarly, tension in the second one, so T equals to block 2, it is connected to pole. Okay, so how much this one? This is the my 20 plus this one 20 and this one is 50. So T equals to 20 plus 50, that is 70. So 70 you can put here. So what is the my F? F is 90 plus 70 plus 50. Okay, so this value you can get 210. That is your final answer beta here. Okay, next one. So the voltage regulation circuit of considering a Zener diode having the breakdown voltage is 10 volt. Okay, and the maximum power dissipated is 0.4, is operate at 15 volt. Okay, the approximate value of the protective resistor to the circuit. Okay, first I will draw the circuit diagram. Okay, so voltage operate at 15 volt. Okay, Zener diode breaking voltage 10 volt. Okay, and power dissipated PD equals to 0.4 watt equals to P equals to all of you know V into I. So 10 into I. So how much current is flow in this one circuit? So I equals to 0.04 ampere. So what they will ask, what is this resistance? So resistance R equals to 50 minus 10 divided by current of this one 0.04. Okay beta, so this one you can solve 5 divided by 0.04, this value is my 125. Okay, so the final answer of this one is 125 ohm, because this is the circuit. So just you can go here to here, this is the, again you can consider a battery and just you can apply KCL. Okay, next one. So a gas of certain mass filled in a closed cylinder means my volume is constant here. At a pressure of 3.23 kilopascal, his temperature is 50 degrees Celsius. The gas is now heated to double its temperature. The modified pressure is, because it is the closed container, so my volume is not changed, so my P is proportional to T. Okay, so just you can take the ratio of P1 by P2 equals to T1 by T2. So initial its pressure is 3.23 kilopascal. Okay, final answer in only for pascal into 10 to the power 3 divided by P2 equals to its initial temperature is 50. So the gas is now heated to double its temperature. Okay, so 50. Okay beta, so 50 plus 273. Second condition 100, because its temperature is now double, so 50 plus 200 plus 273. So just you can solve this one. So P2 equals to how much you can get? P2 equals to 3730 pascal. Just you can do the cross multiply. Okay beta, 3730. Okay. So this is a short bar magnet placed with its axis of 30 degree and external field of 800 Gauss. Experience the torque is this one. So the work done to moving it from most stable to unstable position. Okay, so what is the tau equals to magnetic moment? Tau equals to mb sin theta. Beta, B is given, but in Gauss that is not CGS SI unit. So just we can multiply 10 to the power 4, that is in Tesla, that is the my standard unit, SI unit. Okay, so tau equals to given 0.016 and angle of this one is most 30 degree. Okay, so sin 30 value is 1/2 and B is my 800 into 10 to the power minus 4 Tesla. Okay, so just everything you can put here. So 0.016 equals to m magnetic dipole. Okay, and so m value you can get here. Yeah, otherwise you can do one thing, ki m and b ratio you can get here, because W equals to work done from stable to unstable means direct reversely this one. So W equals to m b cos of theta 1 minus cos of theta 2. So theta 1 is 0 and theta 2 is 180. So W equals to mb, this cos theta is my 2 times 1 minus 1, because theta 2 is this will be my 0 and this will be my 180, cos 180 value is minus 1. Okay, so W equals to 2 times of mb. So mass m and b value you can get easily here. So just you can multiply with this one. So that value you can get 64 into 10 to the power minus 3. Okay beta, otherwise you can do one thing, m value you can find here, that value m equals to 0.16 into 2 divided by 800 into 10 to the power minus 4. So just solve this one and m and b value you can again put here, and 2 times of mb just you can multiply. So 64 into 10 to the power minus 3. Okay, and the last question, 64 raindrops of radius 1 mm each is falling down with the terminal velocity of 10 centimeter per second closely from the bigger drop. So the terminal velocity of bigger drop is, okay, close to from a bigger drop. Okay, 64 raindrops means in this way 60 are making only big drop. So its radius is r and its radius is capital R. So just my volume is constant here. So 4/3 and number of the balls equals to r cube. Okay, so 4 pi to 4 pi is cancel out beta here, and r equals to you can get 3r. So the relation between, so what is the my terminal velocity? Vt equals to 2 by 9 neta r square g into rho minus sigma. Okay, so my V terminal velocity is directly proportional to r square beta. So just you can take the ratio of V1 by V2. Okay, first one velocity is given 10 centimeter per, so V1 by V2 equals to R upon R whole square. So R equals to, you can put 3R, nine. So V2 equals to 9 into V1, so 90 centimeter per second. So 160, where I will do mistake. Oh, there is 4, bro, sorry. This is the 4. Okay, so 4 means this is also my 4. 4 square is 16. Okay, so V2 equals to 16 into 10. Okay, so the final answer is my 160 beta. So this is the complete paper discussion. Thank you beta for the watching the video. Okay, so this is the complete paper discussion of the JEE Mains 2026 24 shift 1 physics paper discussion. Okay beta, thank you, bye.